I should choose the entire window, yes? Do you see now? Okay. So, in this presentation, we will introduce new fuzzy multi-criteria decision-making model um, for a weapon selection problem. We do it on an example of infantry rifle. So the problem is to choose right model of a weapon and do it effectively. We base on this in this model on so-called technique for order preference by similarity to ideal solution, top-6 method, and this is this method proved to be very effective, and it is based on the distance concept. So here we have two solutions, ideal solutions, positive and negative. So the right alternative is that which is closer to the positive ideal solution and farthest from the negative ideal solution. So in the we construct this model over a so-called Q-rank picture linguistic fuzzy environment. And this kind of fuzzy numbers also prove to be very flexible because it is able, these numbers are able to express such properties like qualitative and quantitative characteristics of expert judgments. So let's start in more detail how the algorithm works. So here W is the weights, criteria weights, and ratings are denoted by R, and alternatives are here denoted by D. So we have M number of alternatives and over N number of criteria. So experts agree on some ratings, and this is decision-making matrix denoted by D. So the algorithm itself is next. On the step 1, we assign experts ratings to the criteria with respect to the alternatives, so we have the matrix, decision-making matrix. On the next step, we have to evaluate the criteria weights, and we do it by formula 3, and we use here the Luca-Termini entropy principle for Q-rank picture linguistic fuzzy numbers. On step 3, we construct a normalized Q-rank picture linguistic fuzzy decision-making matrix, and next step is to identify the positive ideal and negative ideal solutions. We do it by choosing in the proper columns the maximal values and minimal values. And here are D plus and D minus. On the next step, we have to calculate the weighted distances between the alternatives and positive and negative ideal solutions, respectively. So this is done by formulas, proper formulas. Of course, here it's impossible to discuss about how these numbers are operating. I mean, the arithmetical operations, also how they are ordered, and so on and so on. The paper deals with these concepts. On step 6, we calculate the relative closeness of Topsis aggregation as a ranking index for every alternative. And here is the calculated relative closeness by this formula. Here also we are choosing specific functions, strictly decreasing and increasing functions. So these functions are specific. In other case, for example, we choose such functions as is given in Formula 6. So if we have the relative, if we have calculated the relative closeness, so we have, in fact, we have final step to how to rank all possible alternatives by their relative closeness. The greater the relative closeness, the better our alternative. So this is the algorithm. And now let's go to example. Example is pure illustrative, demonstrative. So, of course, we are discussing the infantry rifle, but it will work, of course, for any type of weapon. And so it is easily, everything will be easily transferred to another area. Well, of course, here should be invited the experts who will decide what criteria to choose and what alternatives to consider. And in this case, we assume that we have six criteria, and these criteria are, for example, you can see in the table 1. These are the price, weight, parallel, modularity, usability in different climatic conditions, and recoil system. And we have 5 alternatives. We must follow the specialist of this area in this military direction, and they will have to choose the proper alternatives and proper criteria. Then, well, according to our algorithm, we have the decision-making matrix. Here we see in table 2, these are the Q-rank, picture linguistic, fuzzy ratings, and here is given criteria, calculated criteria weights in table 3. Then, going to the next step, we calculate the relative closeness. In this case, Q is 5. Q is denoted, we say that Q rank, so the rank of our numbers are 5. So we have relative closeness, such numbers. So the biggest has the alternative T2. So, of course, final decision is that, yes, this is the recommended the system, the algorithm recommends to choose D2, alternative D2. So now, as a conclusion, we have to highlight some moments that we consider, of course, the fuzzy topsis approach. So the model can take into account experts' qualitative and quantitative reflections. This is why we choose Q-rank picture linguistic fuzzy numbers. So we have to calculate the weights, and this is done by extension of the De Luca Termini entropy principle. And so by this, the problem of weapon selection is given by this model. This is, I finished, that's all. Thank you.
Thank you for your interesting report. Do anybody have a question? I have a question in this case. In your method, input data is very important. Who defined criteria?
The criteria depends on alternatives, yes?
Yes.
So, of course, the specialists should choose with which criteria to work. Because even here, maybe there are any other criteria against which these alternatives have they are not distinguished difference. So, of course, specialists in this area, for example, in this moment, the specialist of military directions who deals with weapons, infantry, rifles. They know, for example, that there are several options. So which option is better? But it is not quite easy to decide which one, because the requirements may be different. Yes, so criteria, of course, experts decide which criteria to choose and which alternatives to consider.
Thank you. If we have no questions, please share your screen.
Thank you.
Thank you for your interesting work. And next presentation, it's work Nina Zdolby.